Hello everyone and welcome to another lab simulation walkthrough. As always, my name is Alec, and today we get to have a chat about one of my favorite topics in physics 2, circuits. So let's jump right in. As I will probably say at the beginning of all of these videos, go ahead and read through the attached lab manuals theory section and go ahead and try to understand it as best you can. And when you're ready, head over to this website and click on the lab tab. Also, one other thing is that there is another document attached to this lab manuals or to this lab assignment. It's a data sheet that you can use if you would like. Also, it's just kind of a visual guide to help you organize your data if you would like to, so feel free to use that. But in any case, let's get going. So we were told that for the entirety of this lab, we'll turn on the conventional setting here. We will let's see, be using only this ammeter, not the other one. I find this one to be a little less useful. Well, I mean, it does the same thing. It's just a little too simple to use, and if we were doing this in person, we would be using one of these. So we will be using one of these. All right, and we are told to set the wire resistivity to tiny and the battery resistance to 0, which I believe is the default, but I wanted to make sure that we got that in there. And on the bottom right, make sure that we have the battery symbol clicked and not the circuit diagram symbol. It just makes the circuits look a little bit closer to what they would look like in real life. And note that any of these objects can be, anything that we'll be using can be edited by double clicking it, or occasionally single clicking it. It's a little finicky, but in any case. Alright, so we're told to, for the first part, in which we're going to be confirming Ohm's law, which at this point I hope you have learned about in class. So we're going to grab a battery, grab a couple wires, 2 lamps and 2 resistors, and we'll be using these same 2 lamps and 2 resistors throughout the entirety of this experiment. So just don't remove those from the screen. We are told to set one of the resistors to between 10 and 50 ohms, and the other one to between 100 and 120 ohms, and the one that has smaller resistance will be called resistor 1, and the one that has higher resistance will be called resistor 2. So I'm just going to set this one to 25 and set this one to 120, and you can see that the colors change here as I move the resistance, as I move the resistance around. That is because there's actually a color code for resistances, which if we were in class, we would have to use in order to read the resistances of these if we didn't want to directly measure them. And it's this somewhat annoying kind of archaic process by which you have to read the colors and figure out what the resistance of these resistors are. But here we can just click on them and set them, so we're good to go. And then we're told to set one of the lamp's resistance to between 0 and 20, and one of them to between 50 and 100. So I'm just going to turn this one up to 100. Alright, so this is lamp 1, lamp 2, resistor 1, and resistor 2. Okay, so now we are told to do the following for each resistor in each lamp. Attach the battery to it, grab an ammeter, put it in series with that, and then double-click the battery to adjust the voltage to each of these 5 values here, and then record the current at each of those junctures. So after the above, you should have 4 sets of data, 1 for each resistor and 1 for each lamp. So I'm actually going to need another wire here, so let's start with the resistors. Attach this here. And it is a very good idea for you to try to do this on your own if possible, just because it's nice to be able to get an idea of how circuits and things like that work. But otherwise I will show you kind of how to do it. So let's set this battery to, let's see, it says 10 volts. Alright, so now we're going to record the current that's passing through the ammeter. And now you'll notice I built the ammeter in series with the resistor and the battery, and the reason for that is because ammeters tend to have very, very near to 0 resistance. And the reason for that is because, well, and because of that, we build them in series, because when you're measuring a quantity in a circuit, you don't want to alter the quantity that you're measuring with the measurement device, right? So we build ammeters to have very low current or very low resistances, so that when you build them in series with a circuit, they don't edit the value of the current themselves, because you're trying to measure that value. So, okay, it looks like for, let's see, this is resistor 1. At 10 volts, we get about 0.4 amps. So go ahead and mark that down somewhere. I will up it now to 20 volts. And for 20 volts, we get about 0.8 amps. For 30 volts, we get about 1.2 amps, and you'll notice as it's going, these kind of arrows are going faster and faster. That's to represent the flow of current. As we go up to 40 volts, we get about 1.6 amps, and I predict as we get to 50 volts, we will get to 2 amps. So there you go. We started at about I think it was 0.4 and got up to 0.2. And make sure you have those marked down. I will go ahead and disconnect this ammeter and this resistor, and we can move on to the next piece here, which is this resistor. Go ahead and rebuild that circuit. Go back down to 10 volts. All right, so for 10 volts, we're getting about 0.08 amps for the second resistor. At 20 volts, we get about 0.17 amps. At 30 volts, we're getting 0.25 amps. At 40 volts, we're getting 0.33 amps. And at 50 volts, we're getting 0.42 amps. So go ahead and mark those down, and I will go ahead and disconnect this resistor and connect up our first lamp here. So this is lamp 1. Lamp 1 has the lower resistance, so I'm just going to double check. Yep. Okay. All right, so let's bring this down to 10 volts here. And you'll notice that the lamps actually get quote-unquote brighter, like these rays here get more intense as you bring up the voltage, which is just kind of to represent what would happen in real life. As you pass more current or more voltage through these things, they would tend to light up a little bit more. But okay, at 10 volts, the first lamp, we get 0.67 amps. At 20 volts, we get 1.33 amps. At 30 volts, we get 2 amps. At 40 volts, we get 2.67 amps. And finally, at 50 volts, we get 3.33 amps. Okay, so I'll disconnect this now, and then we will bring in the second lamp. Drop the resistance back down to 10. So for lamp number 2, at 10 volts, we get 0.1 amps. At 20 volts, we get 0.2 amps. At 30 volts, we get 0.3 amps. Oh, sorry, 30 volts, 0.3 amps. At 40 volts, we get 0.4 amps. And at 50 volts, we get 0.5 amps. Okay, so that should be all of the data you need for the first portion of the lab. You will be using that to make some graphs and such. But for now, I'm going to disconnect these circuit elements and move on to the next portion. Alright, so moving on to the next section, we are told to keep the 2 resistors and the 2 lamps from the previous section and to set the voltage output of the battery to 25 volts. So I've done that here. Now we are told to build the circuit seen in figure 2 of the original lab manual with the resistors, not using the lamps just yet. And basically that is just, it's going to be these 2 resistors built together with this battery in series. So I'll just build that real quick. And it doesn't have to look exactly the same as it does on that circuit diagram, but it will look relatively similar because many circuit diagrams can look exactly the same. But when you actually practically build them in real life, sometimes they look a little bit different. But anyway, here we go. So this is the circuit that is built on figure 2. Figure 2 might actually have the 2 resistors up here, so I'll just do that. And now we're told to use the voltmeter to measure the voltage drop across each circuit element by placing the 2 probes of the voltmeter on either terminal of those, and then, of course, record that measurement. So this is going to measure the potential difference between 2 different points that you put it on the circuit. So for instance, if I go across the battery, we'd expect it to read 25 volts, which it does, so that's good. And if I put it, I don't know, let's say here, it might not actually read anything because it's not, there's no junction there for it to read it at. And of course, if I put it on the same point here, there's no potential difference at this point because I'm measuring it exactly at this point. But if I measure it across this resistor here, you'll see we get 20.69 volts. So go ahead and mark that down either on your data sheet or in the Excel spreadsheet that you're working with, that for resistor 2, we get a voltage drop of 20.69 volts. And then if I bring it over here, we get a resistance drop, or a voltage drop, sorry, of 4.31 volts for resistor 1. Now we're told to do the same thing with the lamps, and in addition to note which, if either lamp shines brighter than the other. So I will do that real quick. these over here. And I'm just going to double check once they're connected which one is lamp 1, which one's lamp 2. Okay, so this one is lamp 1 and this one is lamp 2. And you'll notice here it looks as though lamp 2 is shining quite a bit brighter than lamp 1. So, and now we're told to just measure the voltage drop across each of these lamps. Of course, the voltage drop across the battery is still going to be 25 volts because we haven't changed that at all. But it looks as though the voltage drop across the first lamp is 21.74, and the voltage drop across the second lamp, or sorry, this is lamp 2, this is lamp 1, my mistake. So the voltage drop across lamp 2 is 21.74, and the voltage drop across lamp 1 is 3.26 volts. Alright, so that should be all the data you need for section 2.3, so I'm going to disconnect this circuit and be back in a second with section 2.4. Alright, so here we are with section 2.4. We are told to keep the 2 resistors and the lamps from the previous section, and to leave the battery at 25 volts, and then we are told to build the circuit seen in figure 3 of the original lab manual with the resistors, not the lamps just yet. And this can be a bit trickier. What this is basically going to be is these, we're going to build the battery in series with the 2 resistors in parallel. So I will show you what I mean by that. This can be a bit tricky. It's much easier to do on the simulation than it is in real life, so that is a plus. Students tend to struggle a lot with this when we do it in the lab for real. But what you're going to do is you're going to connect these 2 resistors in parallel like so, and the reason we call it in parallel should become evident in just a moment here. So right now it's just the 1 resistor built in series, but what I'm going to do is build another resistor in parallel with this guy. Grabbing a couple other wires here. Okay, so now we have current running through both of these resistors, and as you can see, the reason we call it parallel is because it kind of looks like they're parallel to each other. I mean, physicists are universally horrendous at naming things. We kind of just call things as we see them, like, you know, a hole that is black and doesn't allow light to shine through is a black hole, and by that same kind of notion, 2 things that are kind of parallel to each other in a circuit are called parallel. So it's not nothing magical going on here. But in any case, we are now told to build an ammeter in series with each circuit element. Remember, we do this so that we don't edit that circuit, or so that we don't change the properties of that circuit element as we're measuring it. And to measure the current passing through each circuit element and record that. So I'm going to attach a couple wires here to my ammeter. And you'll notice in parallel, when I disconnect one part of a circuit, like so, it leaves the other part of the circuit just fine, because now what we've done is just we've disconnected this part of the circuit, but this is still a complete circuit here, so it gets to keep going. And likewise, if I disconnected this part here, this circuit would be just fine and would get to keep going. So what I'm going to do is break it here, and this is resistor 2. So I'm going to build my ammeter in series with this circuit. And what this should do is make it so that this circuit is now complete, or at least this portion of the circuit is now complete, and we should be able to read a current. So it looks like the current through resistor 2 is 0.21 amps. So go ahead and mark that down. I'll disconnect it, and then of course reconnect it to itself. And now we'll measure the current through resistor 1. The current through resistor 1 is about 1 amp. So you'll notice that the lower resistance here gets the higher current. And there we go. And now I'm going to just measure the current through, across this battery here, or through this battery, the total current. So the total current in this case is 1.21 amps. So that's the current just from the source. And of course what's happening, it goes to the battery, out to the ammeter, back to here, and then just kind of goes around as it would normally. Okay. So next we're told to do to repeat step 4 with the lamps. So I'm just going to disconnect this resistor here and disconnect this one here. It's a lot of clicking because you have to cut off different parts of the circuits. Okay, now this is lamp 1. This is lamp 2. Plug that into the battery here, and you can see in this case it looks like lamp 2 is shining significantly lamp 1 is shining significantly brighter than lamp 2. So keep that in mind as you're going. And first let's take first of all, let's take the total current through the circuit here. So Attach this here, attach this here. We get about 1.92 amps as the total for the circuit. And if I measure the current through lamp 2, if I go in here and here, looks like we're getting about 0.25 amps through lamp 2. And if I measure the current through lamp 1 here, looks like we get a current of about 1.67. So that should be all the data you need for the entire lab. Of course, if you have any questions with the data analysis, which I will not do for you here, do feel free to send me an email or drop by my question session and we can talk about it live. Or, of course, we can always set up a time outside of that to talk in, well, quote unquote, in person online. So hopefully this lab or this video has been of some help to you. Again, if you have any questions or need any help, feel free to reach out. Have a good day.